Yeah, so let me start by introducing myself. My name is Doug Balog. I run the Power server business from IBM. That's everything from research and development through marketing to sales to the whole business responsibility. So I'm kind of at the lowest level of the stack. I'm at the hardware level, and I love being there. So the way in which we think about the Power product and Power processor is really is a processor designed for big data. And so as my team and myself got introduced to Neo4j, we sort of saw that perfect marriage coming together. The needs of a graph database, a leadership graph database that Neo4j brings to the marketplace, but then more than just the software in the database itself, it needed a first-class platform designed for big data to run on. And that's where Power and the POWER8 processor with its kind of acceleration capability found that perfect coming together. So we're pretty excited about Neo4j plus IBM Power and the value it can bring to the many clients around the world looking for really a scalable platform for their graphs database. Yeah, so as with Neo4j version 3.1, right, there's an incredible thirst and benefit to having the data close to the computer or the data close to the processor. And so one of the innovations we've worked on together is taking what's already a fairly large memory space, anything from 1 or 2 terabytes at the smallest system up to 16 terabytes at the largest system we offer. So pretty good scalability there. But then really how do you even expand beyond that by leveraging sort of new flash and memory technologies that begin to bring flash into the memory domain. And so we've got a technology called CAPI Flash. It's a way for flash technology to look like memory. And we've done that together so that our memory space, again, fairly large already, can be extended to even be bigger than that. I mean, we all know a graph database benefits from the more data, the more relationships captured, the better the insights of what those relationships have to bear. That's back to the point of the marriage between a graph database and a system designed for big data. That's where kind of CAPI Flash fits in there. So it's a pretty exciting time to be in the hardware business again. We're sort of moving past an era where, for the most part, we were writing manufacturing processes, the way in which systems got faster and faster, and therefore delivered value to workloads like Neo4j, graph databases. We're kind of into a different era right now. It's an era where Moore's law is dead, and I'm not sure if folks really understand what that means because we've been also used to that double the transistor density, double performance every couple years, and therefore workloads just run faster based on manufacturing processes. Laws of physics are getting in the way. Darn those laws of physics, right? They're getting in the way of continuing to see that double the performance. There'll be performance gains node to node, but nothing like 2x. There'll be 30, 40, maybe even 20%, but not 2x. So we needed a different model. And in our view, the disruptive thing happening in the marketplace is this marriage between a really good general purpose processor and a whole set of purpose-built acceleration technologies. By the way, flash and memory are one of those acceleration technologies, but it's I/O technology as well too. It's FPGAs for field programmable gate arrays. Don't worry, you don't have to program them. Others will do the special built programming for them. Or it's GPUs. That whole set married with a really great processor like POWER8 is where we think the world's going forward. And I don't think it's going to change because, again, unless there's a breakthrough, which there probably will be someday, what we know around CMOS technology is we're kind of starting to run out of steam, and applications in this big data world absolutely thirst for data, and they want to run faster. And we do have the answer to that today. So it's pretty interesting to understand kind of the history of the Open Power Foundation. It starts with a group of 5 big thinkers in the industry getting together, IBM, Google, Mellanox, NVIDIA, and Tyan, a motherboard company, really sitting down and sharing a vision for this reality of Moore's law is coming to an end, but then also the need for a new approach in which innovation occurs and workloads continue to run faster. So as we kind of got together and brainstormed what that would look like, we said, let's utilize what exists in the industry in various models today. One is the open source innovation model we all know and love around software. Why not take that open source model and bring it to hardware? No one really had ever done that before, but let's do that. Second thing was, kind of leveraging the ARM processor licensing model that we've seen work very successfully and seeing, therefore, the proliferation of ARM processors into all of our mobile devices, right? I mean, ARM is the dominant player in the mobile device space, right? So we kind of took both of those models and brought them together and created the Open Power Foundation a little over 2 years ago. Started with 5 guys sketching it out on a napkin, and now as we sit here today, it's over 260 companies around the world that are part of this, have created hundreds of innovations, dozens of product offerings in the marketplace, and we're seeing phenomenal success for these offerings in high-performance computing, high-performance data analytics, kind of the commercial derivative of that, in big data and graph databases, as we've talked about with Flash plus Neo4j, and really in anything that's got a thirst for moving data around that wants to accelerate the outcome, as well as do it at scale. So that's the history of the Open Power Foundation, and what's happened in 2 years has been amazing to watch as that community really has solidified around the reality of what's going on in the marketplace and what we as hardware vendors, remember at the lowest level of the stack here, have to do to support the workloads of tomorrow and today around big data and analytics. Final point I would make here would be this is a disruptive time. It's a disruptive time for companies, it's a disruptive time for vendors like myself, and you have to be comfortable disrupting yourself. If you're not, somebody else will disrupt you. That's why we've been boldly going down the path with Power of disrupting ourselves with technology innovation, with new ecosystems like the Open Power Foundation, and partnerships with Neo4j and a long list of other data providers, but also in business model. That final piece is so important because you have to rethink your business model as you go through those other disruptive phases. That's what we've done with the Power business. We're a very different business than we were when we started decades ago, and we're very much aligned with the cloud and cognitive era we find ourselves in today.